Something changed in 2026 that most developers haven't noticed yet. Rust is now inside the Linux kernel. Not as an experiment. Not as a side project. As an officially supported second language that kernel developers are actively using to write drivers, file systems, and subsystems. Meanwhile, Zig just went mainstream, not through enterprise adoption, but through a JavaScript runtime called Bun. Millions of Node.js developers are now running Zig code every single day without even knowing it. The C replacement conversation isn't theoretical anymore. It is happening right now. And you need to pick a side. But here is the problem. Most Rust versus Zig comparisons get it wrong. They treat these languages like they are competing for the same developers. They are not. Rust is not trying to be a better C. Rust is trying to be a safer systems language with a completely different programming model. Zig is explicitly trying to be a better C. Those are fundamentally different goals. If you pick the wrong one for your goals, you will waste months fighting a language that was not designed for what you're trying to do. In this video, I am going to give you the honest 2026 comparison. Not the generic Rust has safety, Zig has simplicity take that every other video gives you. I am going to show you exactly where each language wins, where each one fails, what the job market actually looks like, and which one you should learn based on what you actually want to build. No fence sitting, no safe answers. Just the truth. Let's go. Before we dive in, I want to talk about Aarambh Dev Hub's partner, CodeCrafters, and this one I actually mean it when I say it is a good one. If you have been watching Aarambh Dev Hub for a while, you already know that we are all about understanding how things actually work under the hood. Not just using tools, but truly understanding them. Why does Redis work the way it does? How does Git actually store your commits? What is really happening when you type a command in your shell? CodeCrafters is built around exactly that same curiosity. CodeCrafters is a platform where you rebuild real developer tools from scratch. Things like Git, Redis, a shell, an HTTP server, a DNS server, a BitTorrent client, you actually build them yourself, stage by stage, in your own language. Every stage unlocks the next, and you can see exactly how far along you are as you go. Now the most popular language on CodeCrafters is Rust, and that makes total sense for this channel. If you're just getting started with Rust and want to learn it the right way, this is honestly one of the best approaches out there. Instead of reading theory or doing small exercises that go nowhere, you sit down and build something real. Something you have actually heard of. Something that exists in the real world. And that is when Rust really starts to click. This is not your typical tutorial platform where you just watch someone else code and feel like you learned something. You are the one writing the code. You are the one debugging it. You are the one making it pass each stage. That kind of active, hands-on learning is what actually makes you a better systems programmer, and I will be honest. It is genuinely a lot of fun. The challenges are used by engineers at companies like Google, Meta, and Shopify. And if your company has a learning and development budget, there is a very good chance CodeCrafters is covered under it, meaning it could cost you absolutely nothing out of pocket. Worth checking with your manager before you pay yourself. The link is in the description below. Check it out, and if you do sign up through it, you also directly support Aarambh Dev Hub, so thank you in advance if you do. Alright, now let us get into the video. Let me set the stage, because 2026 is different from 2024 in important ways. On the Rust side, the Linux kernel merge was the big signal. Linus Torvalds approved Rust as a second language for kernel development. Multiple drivers have been merged. More are in active review. Google is funding Rust kernel development. Microsoft is adding Rust to the Windows kernel. Android has been expanding Rust usage for years now. The message from the industry's most important C codebases is clear. The doors are opening to Rust. On the ecosystem side, Rust's async story has matured significantly. Axiom has become the default web framework. SQLX and CORM are production-proven. Tokio is stable and fast. The argument that Rust Backend isn't ready is basically dead in 2026. On the Zig side, the story is different but equally important. Bun, the JavaScript and TypeScript runtime built on Zig's JavaScript core, has exploded in popularity. It is faster than Node.js for many workloads. It ships with a built-in bundler, test runner, and package manager, and under the hood, it relies heavily on Zig for its systems-level performance. Millions of developers are now indirectly using Zig every day. Tiger Beetle, a financial database written entirely in Zig, is processing billions of dollars in production. It is real-world proof that Zig can handle serious, safety-critical systems work. And that Zig is dead narrative that popped up in some corners of the internet, it was wrong. Zig versions 0.13 and 0.14 brought significant improvements to the self-hosted compiler, better error messages, and stronger standard library patterns. But, and this is important, Zig still has not released version 1.0. The language is still technically in development. The package ecosystem is still young. The number of production Zig codebases is still small compared to Rust. That asymmetry matters. And anyone who tells you it doesn't is not being honest with you. So now that we know the 2026 landscape, let's get into the real comparison. Every Rust versus Zig comparison talks about safety versus simplicity. That is not wrong, but it misses the deeper point. When you choose Rust, you are choosing to let the compiler enforce rules about how memory is used. You are saying, I am willing to learn a complex type system, fight with the borrow checker, and structure my code in specific ways, because in exchange, the compiler will prevent entire categories of bugs. When you choose Zig, you are choosing to keep that responsibility yourself. You are saying, I want to understand exactly what my code is doing at the machine level. I want to see every allocation. I want to control every lifetime. And I am willing to accept that I might make mistakes, because the language will never hide what is happening from me. These are not just technical choices. They are philosophical choices about how you want to relate to the machine. Think of it this way. Rust is like driving a car with advanced safety systems, lane assist, automatic braking, collision detection. You still drive, but the car intervenes when you make dangerous mistakes. Zig is like driving a manual transmission car with no electronic aids. You have full control, you feel every gear change, you know exactly what the engine is doing. But if you downshift at the wrong speed, the car will not save you. Some drivers prefer the safety systems. Some prefer the direct control. Neither preference is wrong, but they lead to very different experiences. The reason this matters is that your philosophy preference will determine how much friction you experience daily. If you choose Rust but you hate being told how to structure your code, you will be miserable. The borrow checker will feel like an opponent, not a tool. If you choose Zig but you actually wanted the compiler to catch your mistakes, you will be nervous. Every manual allocation will feel like a potential bug. So before we compare features, understand this, you are not just picking a language. You are picking a relationship with the machine. Memory safety is Rust's killer feature. And in 2026, it matters more than ever. Let me give you the context. The White House released a report urging the technology industry to move away from memory-unsafe languages like C and C++. Google reported that 70% of their serious security vulnerabilities in C and C++ code are memory safety bugs. Microsoft said roughly the same thing. The NSA published formal guidance on adopting memory-safe languages. This is not hype. This is governments and trillion-dollar companies saying, the cost of memory-unsafe C and C++ code has become unsustainable. Rust's ownership system directly addresses this. In safe Rust, you cannot have use-after-free bugs. You cannot have double-free bugs. You cannot have data races in concurrent code. You cannot have null-pointer dereferences the way C does. The compiler enforces these rules at compile time. Not at runtime, not through a garbage collector, through static analysis that proves your code is safe before it ever runs. This is why the Linux kernel accepted Rust. This is why Android is rewriting components in Rust. This is why Cloudflare, AWS, Microsoft, and Google are investing heavily. The argument is simple. If a bug category can be eliminated by the language, why would you keep writing code that allows it? Now, Zig's position on this is intentional and worth understanding. Zig does have safety improvements over C. It catches integer overflows in safe build modes. It uses optional types instead of raw null pointers. It has explicit error handling without exceptions. It makes allocations visible, but Zig does not have a borrow checker. It does not prevent use after free at compile time. It does not prevent data races through the type system. Zig's argument is, the programmer should have the control, and the language should make the control visible, not automatic. For a solo developer working on a well-understood codebase, that can work fine. For a team of 50 engineers working on a security-critical system, Rust's compile time guarantees start to look very attractive. If memory safety is your top priority, Rust wins this category. Not by a little, by a lot. But now let's talk about where Zig genuinely excels, because this is not a one-sided comparison. Zig is simple. Not simple as in easy to learn in a weekend. Simple as in the language has a small number of concepts, and those concepts compose predictably. There is no borrow checker. There are no lifetimes. There are no traits. There are no macros. There is no preprocessor. There is no hidden control flow. There is no hidden memory allocation. What you see is what the machine does. Period. For C developers, this is a revelation. If you have spent years in C, you know the pain. The preprocessor is a mess. #def blocks make code unreadable. Build systems are a nightmare. Cross-compilation requires toolchain juggling. Header files create dependency chaos. The language has decades of accumulated complexity. Zig takes all of that away while keeping the mental model you already have. You still think about memory manually. You still understand pointers. You still control layout. You still know what the machine is doing. But the language is cleaner. The errors are better. The build system is built in, and cross-compilation works out of the box. For a C developer, Zig feels like someone finally fixed your favorite tool instead of replacing it with something alien. And then there is Zig CC. This is Zig's C compiler mode, and it might be the most underrated feature in modern systems programming. You can point Zig CC at a C or C++ project and cross-compile it for dozens of targets without setting up any toolchains. No installing GCC for Aarambh, no configuring cross-compilation flags, no wrestling with sysroot. You just run Zig CC and it works. For embedded developers, for people maintaining C codebases, for anyone who has ever cried over CMake cross-compilation, this feature alone is worth looking at Zig. Rust has nothing like this. Rust's cross-compilation story has improved, but it is not at Zig's level. This is where I have to be blunt. Rust's ecosystem in 2026 is massive. Crates.io has over 150,000 crates. For almost any problem you need to solve, HTTP clients, database drivers, serialization, cryptography, CLI parsing, logging, tracing, testing, benchmarking, WebAssembly, GUI, embedded, there are multiple mature, well-documented options. Tokio gives you a production async runtime. Axum gives you a modern web framework. SQLX gives you compile-time checked SQL. CERD gives you serialization that feels like magic. Clippy catches mistakes. Rust FMT keeps code consistent. Cargo ties it all together. The daily developer experience in Rust is excellent in 2026. Not perfect, compile times can still be frustrating, and some crates are better maintained than others. But compared to almost any other systems language, Rust's ecosystem is in a different league. Zig's ecosystem is growing, but it is years behind. There is no crates.io equivalent at this scale. The package manager situation has been evolving. The number of libraries is small. Documentation is scattered. Production examples are few. If you want to build a web API in Rust, you can have a working server with authentication, database access, and error handling in an afternoon. In Zig, you will be writing more of that infrastructure yourself. Now, some Zig developers see this as a feature, not a bug. They argue that fewer dependencies means more control, fewer supply chain risks, and better understanding of your code. And there is some truth to that. But in 2026, if you need to ship a production system quickly, Rust's ecosystem advantage is not small, it is enormous. I am going to keep this section short because the performance comparison between Rust and Zig is mostly boring. Both languages compile to native code. Both can achieve C-level performance. Both give you control over memory layout and allocation patterns. Both have optimizing compilers that produce efficient machine code. In benchmark after benchmark, Rust and Zig end up in the same ballpark. Sometimes Rust is faster because its abstractions compile away cleanly. Sometimes Zig is faster because it has fewer hidden costs. The more interesting question is not which is faster, but which makes it easier to write fast code. Rust lets you write high-level code, iterators, enums, pattern matching, generics, that compiles down to efficient machine code. You get performance without thinking about it most of the time. But when you need to optimize, you can drop down to unsafe Rust and control everything. Zig makes performance more explicit. If you allocate, you see it. If you copy, you see it. There is less magic optimization happening behind the scenes. Some developers find this more predictable, others find it more tedious. Both approaches work. Choose the mental model you prefer. If your world involves C code, and in systems programming it usually does, Zig has a genuine advantage. Zig can import C headers directly, not through a binding generator, not through an FFI layer, directly. You write @import with @conclude and you have access to the C functions, types and macros. Zig can compile C code. Zig can link C libraries. Zig can act as a drop-in C compiler through Zig CC. If you're working on a project that lives in the C ecosystem, Zig fits in naturally. Rust's C interop is good, but it is a different experience. You use the extern C block. You use bindgen to generate Rust bindings from C headers. You use C bindgen to generate C headers from Rust code. You manage raw pointers, ownership boundaries, and error conventions manually at the FFI boundary. It works. It is production proven. Many major Rust projects wrap C libraries this way, but it requires more setup and more careful design. Think of it this way. Zig is designed to live alongside C, Rust is designed to wrap C safely. If you are gradually replacing C code in an existing codebase, Zig might be the smoother path. If you are building a safe Rust application that needs to call a few C libraries, Rust's FFI is perfectly fine. For backend web development in 2026, Rust is clearly the stronger choice. The async Rust story has matured. Tokyo is rock solid. Axum has become the community's favorite web framework. It is fast, ergonomic, and well documented. SQLX gives you compile-time checked SQL queries. Aarambh provides a full-featured Aarambh. Tower gives you middleware and service composition. Tracing gives you structured logging and observability. You can build a production API server in Rust today with confidence. Companies are doing it. Cloudflare workers run Rust. Discord runs Rust. Figma runs Rust. Many startups are choosing Rust for their backend from day one. Zig can build servers. The standard library includes HTTP server support, but the backend ecosystem is minimal compared to Rust. There is no mature async runtime at Rust's level. There is no widely adopted web framework. There is no ORM. There are fewer middleware options, fewer database drivers, and fewer production examples. If you want to build a backend in Zig, you will be writing more infrastructure from scratch. That can be rewarding if you want full control. But if your goal is to ship a production API quickly, Zig backend development is not the practical choice in 2026. Rust wins backend. This is not close. Let me talk about something most comparison videos ignore: money. In 2026, Rust jobs are real and growing. Not just at FAANG companies. Startups, fintech companies, blockchain projects, cloud infrastructure providers, security firms, and game studios are hiring Rust developers. The salaries are above average. The demand is outpacing supply. Zig jobs exist, but they are rare. You might find positions at companies using Bun, at Tiger Beetle, or at specialized systems programming shops. But the volume is a fraction of Rust jobs. Now, if you are learning a language for personal projects, for fun, or for open source contribution, the job market matters less. Zig is a fantastic language for personal systems programming projects. It is fun, it is educational, it will make you a better programmer. But if you are making a career decision, the data is clear. Rust has significantly more job opportunities, more company adoption, and more resume value in 2026. I am not saying this to dismiss Zig, I am saying it because you deserve honest information. If this comparison is giving you clarity on Rust versus Zig, do me a favor. Hit the like button. It takes 1 second and it tells YouTube to show this video to more developers who need to see it. Subscribe if you want honest systems programming content every week. No fluff, no sponsor segments disguised as content, just real comparisons. Let's keep going. Okay, decision time. Here is my framework. Learn Rust first if any of these describe you. You want to work on production backend services or cloud infrastructure. You care about memory safety and want the compiler on your side. You are interested in WebAssembly, blockchain, or security-critical systems. You want the strongest possible resume in systems programming. You want access to the largest ecosystem of libraries and tools. You are building for a team, not just yourself. Rust gives you the most options and the most career value in 2026. That is just the reality. Learn Zig first if any of these describe you. You are a C developer who wants a modern language without abandoning your mental model. You work on embedded systems and need better cross-compilation. You are building or maintaining C toolchains. You value simplicity and explicitness over compiler-enforced safety. You are building a project where you want minimal dependencies and full control. You find Rust's learning curve too steep for your current situation. Zig is an excellent language for these use cases. It solves real problems that Rust does not solve as well. Now here is the answer that might surprise you. If you have the time, learn both. Not at the same time. But learn Rust first for the career value and the safety mindset. Then learn Zig for the C-like control and the simplicity mindset. Rust will teach you about ownership, lifetimes, safe concurrency, and API design. Zig will teach you about explicit allocation, simple control flow, build systems, and low-level clarity. Together, they make you a much stronger systems programmer than either one alone. But if you can only pick one today, pick Rust. You can always learn Zig later. The job market, the ecosystem, and the industry momentum are all pointing in Rust's direction. Let me give you clear winners by category. Memory safety, Rust. Not even close. The borrow checker eliminates bug categories that Zig leaves to the programmer. Simplicity and explicitness, Zig. Rust is powerful but complex. Zig is smaller, more direct, and more predictable. Ecosystem and libraries, Rust. Crates.io, Cargo, Tokio, Axum, SQLX, CERD, the depth is unmatched. C interoperability, Zig. Direct header imports, Zig CC, seamless C compilation. Zig was built for this. Cross-compilation, Zig. One command for dozens of targets. This is Zig's best developer experience. Backend development, Rust. Mature async runtime, web frameworks, ORMs, and production examples. Embedded systems, Zig is stronger for C-heavy embedded work. Rust is stronger for safety-critical embedded work. Split decision. Learning curve, Zig is easier to start. Rust is harder to learn but rewards you more over time. Job market and career value, Rust. By a significant margin. Community momentum in 2026, Rust has the volume. Zig has the curiosity. So who wins overall? If I have to give one answer, Rust wins in 2026. It has the ecosystem, the jobs, the safety story, the production adoption, and the industry backing. But Zig wins something important that Rust does not, the heart of C developers who want a better tool without a completely different philosophy. Rust is not trying to replace C on C's terms. It is offering a different approach to systems programming that happens to be safer. Zig is explicitly trying to replace C on C's terms. Same mental model, same control, same explicitness, just better. Both projects are valuable. Both will likely coexist for a very long time. But if you are making a choice today, for most developers, in most situations, Rust is the practical answer. If this video gave you a clear answer on Rust versus Zig, hit the like button. Subscribe to Aarambh Dev Hub for more honest systems programming comparisons. No bias, no fluff, just real analysis. Drop a comment below. Are you Team Rust, Team Zig, or are you still writing C and ignoring both of them? I read every comment. Check the description for related videos, Rust versus C++, Go versus Rust for backend, and is Rust replacing C in 2026? Join the Discord if you want to talk about this with other developers. And if you want to support the channel, Buy Me a Coffee and GitHub sponsors links are in the description. Thanks for watching. Happy coding.